Hi everyone, Professor Ullman here. Last time we talked about volume by slicing and I used a number of line drawings of solids that were sliced, and let's be honest, the drawings weren't very good. So I wanted to give you a little bit more of a sense of what these solids look like that we're talking about. So fortunately, some people have actually made some pretty good models of these. Let me just share those with you. So, for example, here's a solid where the cross sections are rectangles. Looks a little bit like the ones we were talking about where the cross sections were squares. So as you can see, these rectangles grow out of a base in the plane. That's this one. This one has a semicircular cross section, so it looks like the base is a triangle, but the cross sections are semicircles. And oh, here's another one. Again, probably with triangular base, but the cross sections themselves are semicircles. And here's one with actually looks like an elliptical base. You can see the curvature. If you look at the pencil marks on the paper, you can see the curvature. So that's an elliptical base with triangular cross sections. I actually made a few of my own models, but I can't claim that they're as good. As you can see, I made them out of some styrofoam that I got from Home Depot. And so this is, see if you can see it, this is a triangular base with semicircular cross sections. One thing you can tell about this is that it's actually been held together with toothpicks. So one of the problems is, although I used to pass these around class, you could actually stab yourself on the model, so that's not good. I also made this one. This one has, it's actually a parabolic base with triangular cross sections. Problem with this is it's actually very small. If you look at this tiny little piece of a styrofoam triangle, I meant to make it bigger. I created an Excel spreadsheet to calculate the size of the triangles I had to cut, and unfortunately, I was off by a factor of 2. So I made this model much smaller than I intended to. It's actually reminded me of a movie from the 1980s called This Is Spinal Tap. If you've ever heard the phrase, R's go to 11, it comes from that movie. It's a phrase that's so famous that it actually has its own Wikipedia page. But there's another scene in the movie where they had the band. This is it's a movie about a fake documentary about a fake band. They had a song called Stonehenge and decided to commission a model of Stonehenge to be displayed while they were performing the song live. Unfortunately, they got the scale wrong. They got feet and inches mixed up, and the model ends up being much smaller than it was supposed to be. Let's take a look at what happens.
I do not, for one, think that the problem was that the band was down. I think that the problem may have been that there was a Stonehenge monument on the stage that tended to understate the hugeness of the object.
Nigel gave me a drawing that said 18 inches, all right?
I know he did, and that's what I'm talking about.
Whether he knows the difference between feet and inches is not my problem.
So the moral of the story is get the scale of your model right. Anyway, we're going to talk now about a type of solid where the cross section has a very specific type of shape. That shape is actually hinted at in the image of the lion that introduced this video. So what am I talking about? Let's take a look.